Hi, good morning and welcome to the ZP Developer Zone. So we do this webinar every Thursday at 8 a.m. London time, and I will jump into it. We show this slide and we say, welcome to the ZP Developer Zone. It's probably worth knowing that we have the ZP Academy. So if you want to learn about electrochemistry, you can find out that in ZP Academy. We do this webinar every Thursday at 8 a.m. London time. We do have collaborations. I mean, for example, we have one of our ZP Developer Zone members coming in from Turkey this summer to work with us. We offer jobs and we post jobs through this forum, and we also have the ZP Developer Zone website. And we also have a workshop. And we have a workshop on CGM being held in Norway this winter coming. So what I want to do now is jump into the questions, and one of the questions is this question came in from Singapore, and the question was around our silver chloride reference electrodes, and I will address that and talk about its sensitivity with pH. I just want to say hi to Aftab. Nice to see you this morning, Aftab. The second question then is a particular collaborator is having a problem with measuring vinegar and sodium bicarbonate on the ecFLEX. This is something that we've actually done ourselves. When the person was struggling, we did have a go ourselves, and it was successful. So I'll report on that. We've also had an inquiry about measuring CBD and THC. So there's now legal uses of things like hemp in some countries, and when you're growing hemp, you need to ensure that the sort of CBD levels sometimes are high, but you definitely don't want the THC levels to be low. So we'll talk about that as well. And rather, you want the THC levels to be low. We'll also talk about customization of screen printed electrodes. Lots of people want customized electrodes. Sometimes they just want their own brand on the electrode. So we'll also talk about that as well. I have had this inquiry before where it's got a lack of glucose response. They're formulating a glucose sensor using the ZP activation solution and the ZP barrier layer. They can test up to 2 millimolar and get a linear response, but after 2 millimolar they get no response. And we'll discuss that because I think we've definitely we've solved the mystery. So I want to dive into it. So the first one is it's nice that people are sort of following the videos and stuff like that online, and the question was we know you can make a sort of chloride resilient electrode, but is it pH sensitive? So I will jump into that now and say what we're doing is, on many of our electrodes, you'll know that we have a sort of silver chloride electrode on them, and that is meant to be stable, but it's only stable if the chloride is stable. It can then put this resilient layer on it, and then the question is silver chloride intrinsically pH sensitive? So the answer is silver chloride has a reputation for not being pH sensitive. When you look at the basic chemical equations, then you don't expect it to be, but that doesn't mean you shouldn't test these things. There can be phenomena that you don't understand. So we have actually been testing it recently for some internal reasons. So in the picture, you can see we've got a couple of cables because we're just measuring potential, so we only need sort of essentially 2 cables. There's little beakers, and in the beakers we've actually got one of our SPEs, one of our screen printed electrodes, and in there we've also got a silver chloride reference electrode. So I've sort of zoomed in a bit. The picture's a bit blurry, but I've also got a bit of a cartoon, so I'll show you the when I say cartoon, I mean little sketch here. We've got the true, let's say, reference electrode, which is glass, one of these glass sort of barrels full of saturated, probably potassium chloride, and we've got a silver chloride wire in the middle. So it's a sort of true silver chloride, and then we've got one of our SPEs, and we're just measuring. We've got them in wet contact with each other, and we're just measuring the voltage between the two electrodes. Now, what we're showing here is we have signal. So when you look at this, I'll read it to you because it's a little small, but let's say the scale on this is actually 20.6 to 22.4 millivolts. So that's really only a scale of something like 1.8 millivolts. It's tiny, it's absolutely tiny. The kind of signals we're expecting if something's pH sensitive are often things like 59 millivolts per pH. So have this sense that 59 is the kind of, we call it Nernstian behavior, but this is actually, the whole scale here is less than 2 millivolts. So what we've done is we've measured our screen printed silver chloride versus a true silver chloride, and we tested at pH 2, pH 4, and pH 6. So if we look at pH 2, we have a distribution in signals from 22.4 millivolts to above 21 millivolts. So a very small distribution was definitely experimental error. These are so small numbers, that. So at pH 2, we measured, 3 electrodes. We got 3 results, and the distribution only looks like that because we're essentially zoomed in so much. Then we go to pH 4. Again, we get very tight, not a lot of distribution in values. And then we go to pH 6. So what this says to you really is we have a true silver chloride reference electrodes. It's a silver wire inside its own sort of probably 1 molar potassium chloride solution, and then we're measuring our reference relative to it, and then we're changing the pH, and we're really not getting a signal that has we're not showing a signal proportional to pH. These are actually very small distribution in values. If anything, it says, what a good reference ours is, because this is essentially made up of 9 reference electrode data points, and they're all looking pretty good. So I think it's fair to say that we don't have a pH sensitive silver chloride electrode, which is what we would expect. But I think in reality, you have to actually sometimes test things, because in experimental science you discover new phenomena that you weren't otherwise expecting, but we have tested it. All right, so that was question number 1. All right, question number 2. This is an interesting one, this arrived on our plate a few weeks ago, and the question at the time was, we've got your ecFLEX, we've got a pH sensor, and we're trying to measure. They were trying to test with vinegar and sodium bicarbonate. So we actually ended up doing that work ourselves. I'll bring this back a few times. This is a snapshot from Julie. So Julie is this cloud database. It's free for academic use, and you can store all your data in there and analyze it. So we use it, as a sort of electronic lab notebook. It's particularly good at electrochemical data, and we got a little picture in the database where we took a little ecFLEX with a pH sensor on it, and we dipped it into vinegar, and we dipped it into sodium bicarbonate, and we actually got the results were in the positive region, or the positive voltage, which was what we were expecting, and they were actually changing whether we went from bicarbonate to vinegar and vinegar to bicarbonate, for example. So we were essentially happy with the results. It's just a bit of background on this. The ecFLEX, actually does have 2 types that, so it's worth testing whether you've got the chronoamperometric model or the open circuit potential model. In this particular case, we're talking pH sensing. So obviously the method of choice is OCP, open circuit potential. And it's probably worth knowing that the software is available for download off our website. So all good. Back to the real question now. So what are we expecting from a ecFLEX with a pH sensor? We're expecting to be able to get results somewhat equivalent to this. It's off our website. We're going from things like pH 2 down to pH 9 and then back to pH 2. So now the big thing about this is it's actually connected to the first question this morning, which was ZP electrodes, and in this case, let's say the pH sensor, the reference electrode is silver chloride. So we've often designed these with medical applications in mind. The reason that's pertinent is because in blood, the chloride is fixed at approximately 135 millimolar. So the chloride is fixed. That means our reference electrode is fixed, and therefore our pH electrode can show a pH response a voltage response proportional to the reference electrode. And we know that the reference electrode has a fixed voltage because it's in a fixed chloride. Now I knew that the inquirer was actually using vinegar and sodium bicarbonate, but I didn't mind because I knew there wasn't necessarily chloride in there. Why should there be? But I'm also of the mindset sometimes you have to try things. And actually it seemed to work because we tried it and we were getting these differences in responses. So it's a little bit of a mystery to us why they also can't get this. One of the things the engineers suggested was actually to fix the chloride in their samples. So for example, if you're using vinegar, make a chloride concentration in that vinegar of 0.1 millimolar. And the same with bicarbonate, make a concentration of 0.1 millimolar of chloride in there. The reason being is if a reference electrode, a silver chloride reference electrode, has a voltage that's proportional to chloride. So if you're at 1 molar of chloride, then you may have a voltage of approximately 220 millivolts. And if you're at 0.1 molar, then you might, it says, yeah, that's right, 0.1 molar, you might have a voltage of more like 277 millivolts. So if I was to summarize the situation, ecFLEX works with the pH sensors. We have tried vinegar and bicarbonate, works great. The only mystery might be, vinegar and bicarbonate. Obviously, we've bought ours from the grocery store. You've probably bought yours from the grocery store. For whatever reason, which is not apparent to me why, they might be different. It might be worth you fixing the chloride concentration in those and just to remove, let's say, at the moment, the undefined chloride concentration in those samples. At the moment, it's undefined because there's actually no chloride in there. Where, of course, intrinsically, if we got a silver chloride reference, then you probably need some chloride in there. Even though we've actually done experiments with unadulterated vinegar and bicarbonate, and we did get some good results. But the nice thing about the ZP Developer Zone is we are willing to discuss these things and have an online conversation about it. I'm going to go to question number 3 now. And question number 3, this is an interesting one. So there is a increasing interest, at least in Europe. I think places like Portugal and Spain, at least Spain, they're starting to grow a lot more hemp. It provides natural fibers. There's an interest in many countries now with using CBD as a sort of natural remedy for various ailments. If you're not sure about this molecule here is CBD. It's a cannabinoid diol, I think, and then this is tetrahydrocannabinoid diol here. People are now, because there's now a legal or market for the growing and use of these products. People are actually interested in being able to detect these molecules and be able to quantify them. So ZP, we actually have done some work, and I say here the word direct. So we have done some direct detection of CBD and THC on our electrodes, and so we know that our electrodes are intrinsically sensitive to these molecules. If people are interested, they can connect with us and contact us. So I say here direct, so we can directly detect these molecules. And we've also done a bit of indirect detection. This is the scheme that we used. You sort of carbon electrode with gold nanoparticles, and then you tether on a thiol, and from the thiol, then you can sort of form a bond with with a macromolecule, and it's the macromolecule that has specificity to the CBD and the THC. I would make immunosensor type assays now for CBD and THC. I just wouldn't use gold nanoparticles, etc. I think it's overcomplicating the situation. So we did do a proof of principle quite some time back on this, and we did get signal versus concentration. The linearity can be improved. It was a bit sort of stepwise, and I think it's really just doing the work more and refining the process. The error bars are not so disturbing to me. I think they need to be decreased. So there is definitely some improvement for this assay. And I think the improvement that I would actually make if we were doing the work again is to just make it simpler. Um, I don't like, I think the gold nanoparticles is a step that's really not required. I've talked about it in other webinars, but actually now I prefer to go from carbon and use pyrene NHS to just directly couple macromolecules to the carbon surface. But that said, if you're interested in CBD and THC and the detection of these things, you can either do it directly on electrodes, and ZP has done that. You can also then do the indirect detection of electrodes using macromolecules, and that's probably give you better specificity, but then it's a more complicated manufacturing and more costly product. So there's pros and cons, and you choose which way you do it based on really on the commercial landscape. What can the market bear in terms of cost? What's the limit detection? What's the consequences of misreading the sample, etc.? You know, if you're going to convict people of crimes based on it, then you really want to make sure you've got the best sensor possible. If you just need an in-field quick test, that's a different quick test. For growers, for example, could be a different dynamics. Customization of electrodes. This is something that's really close to my heart. That there's a propensity in the world of biosensor development and screen printed electrodes to go to customization too quickly. I've talked about it in the past, but the problem is it's an expensive endeavor to make any product repeatable and low cost. Repeatability and low cost often takes a lot of investment. So people want to, for example, they do actually like our hypervalue electrode. So I've got a case at the moment where the guy really likes a hypervalue electrode, and then he wants a customization of it. And what you find out is the only thing he doesn't like about this is he wants to go to market, so he doesn't want the ZP logo on it. So what we've said in this situation is, okay, I get it. When I do these webinars and I speak to, people, I've always with a mindset that actually one day they're going to develop a product, and I understand that they need to brand this themselves. So with the ZP hypervalue electrodes, actually we can just produce them so that in fact the brand is not on there. We essentially just slice it off the top, and then in this case we're actually going to put adherent labels on them and put his logo onto that. So it's just to say that you can have customization while still on a very standard product from us, because for most applications, if you're dealing with the food industry, you're dealing with the healthcare sector, you're dealing with government, it's they're only going to want to see your logo on the product. So we're able to do that quite quickly. So we did for him produce a quick sort of web store item and just say, look, if you need 300 of these, it's a bit of manual labor for us, but we can do it for 350 euros. So it just allows people to start building those business cases and having those prototype products without enduring the cost of really having to go to customization too early. Now, this is an interesting one that's been going on for a couple of weeks now. I have talked about it in the past, but I'll describe it and then we'll go through it. So at Zimmer & Peacock, we make various solutions. One of them is an enzyme solution that you can deposit on an electrode, and the enzyme solution is sensitive to glucose, and therefore you can start making a glucose sensor from it. So we have, we call it CGM activation formulation, and we also have barrier layer. I have talked about the use of the barrier layer in the past, but if I was to describe the problem this person's been having is they have a signal and they're doing an experiment, and they have a signal, and they first put on a sort of buffer solution with no glucose in there. Then they add some glucose, and the signal comes up at 2 millimolar. So they add 2 millimolar of glucose, and they get a signal. But the problem is after that, then they get no more signal. So a couple of weeks ago, or 2 to 3 weeks ago, I did a sort of talk where I said, okay, so they have a substrate on which they have an electrode. Now, the important point I made in that video was, we didn't know what electrode they had. And I sort of was suspicious about it, but, you know, I advised them, you've got an enzyme formulation here. If you're not getting good linearity, maybe you don't have enough enzyme. So I advised they thicken that up. You know, I also advised them that, look, you know, if you're not getting good linearity, sometimes it's the barrier layer. You need to have more, let's say, barrier to stop all the glucose getting to the enzyme. But again, I was suspicious about the electrodes. So now, which is good, you know, this is the part of why we do these webinars, we've actually found out that the electrode that they're depositing onto is a carbon electrode. So the formulation we've given them is for what's called a generation 1 glucose sensor. A generation 1 glucose sensor means that you have glucose oxidase, it reacts with the glucose in the presence of oxygen, you get hydrogen peroxide. Hydrogen peroxide can then be detected on a platinum electrode at 650 millivolts. So this person is probably applying a voltage of 650 millivolts, but it's a carbon electrode. The reason they get some activity is because carbon does have kind of quinone and pyrone moieties on it, which can interact with hydrogen peroxide. It also has alcohol groups on it. So carbon has alcohols and diols on its surface, and these would allow the carbon to interact with hydrogen peroxide. But there's not many, and the reason I know it's not many is because if there were lots of this, then I suspect this person would be having signal above 2 millimolar. So my suggestion is this: roll it back a little bit, get simple before you get complicated again. I mean, you know, get some platinum electrodes. We do use these platinum electrodes ourselves. Put the formulation on there, get everything working. I don't think you really want to stay on carbon. If you do want to stay on carbon, you have to start thinking about mediators. But at the moment, I say just get it going, which is, it's a platinum electrode. Platinum has a lot of catalytic surface for the, you can oxidize hydrogen peroxide on platinum, no problem. So it's the platinum, the carbon electrodes need to be changed for platinum, which I had a suspicion about the electrode. But first of all, I got them to play with the formulation. The changing the formulations didn't work. Then they sent me some more information, and we found out it's carbon. I think carbon is essentially the smoking gun in this mystery. That if you Google and look through the literature, generation 1 glucose sensors are generally made on platinum electrodes. And a data point on that will be that Dexcom, which makes a CGM, is platinum, and Medtronic, who also make a CGM, a continuous glucose monitor, I think they're using platinum black. So I have some, obviously, also understanding from the commercial landscape as well that, you know, platinum is the ones used, and we do use it as well. So I think now the last part of this, at the moment they have a particular cable and they have a particular potentiostat. So they want to know how to connect the platinum electrodes that we have to their potentiostat. So I just want to kind of touch on that a bit. At ZP, all of our electrodes have a pitch of 2.54 millimeters. This is becoming pretty standard. So you look at the electrodes from contact to contact to contact, there's a pitch of 2.54 millimeters. When you're dealing with companies like Palm Sense and Zimmer & Peacock, we're all using the same connector. I'd even throw Drop Sense into there as well, that we're often all using this same connector that has a pitch of 2.54 millimeters. So that means with some skill, you should be able to put ZP electrodes into, for example, a Palm Sense cable. So you should be able to slot them in there. Now, when I look at the picture of the potentiostat that's been sent to me, when I look at this cable, I've got a suspicion that these are banana plugs pushed into some crocodile clips or some alligator clips. So I suspect that actually the best way of interfacing between the Palm Sense that they have and the ZP platinum electrodes that we have are these connectors. But you need a connector with a 7 millimeter slot here for the platinum electrodes that I've been recommending, and you need the connector with a 2 millimeter banana plugs here, the female banana plug connectors here. There's a particular one, so there is. I've just sort of highlighted it here on our website. You know, the one that you actually need. And so that is a good way of getting between. If people have a palm sense, I did check palm sense, and then yeah, that by default their banana plugs are generally 2 mm. So I got it straight from the horse's mouth, as to say. I just noticed that actually it's when you get these solutions from ZP, both the activation solution, the barrier layer, and electrodes. This is and the platinum electrodes, not a too costly way of actually going on making first glucose sensors. Well, I think I'm coming to the end now. I'll just look at the time. And so in summary, silver chloride electrodes, are they pH sensitive? Today I've shown you some data that shows that they're not pH sensitive, which is really interesting because the second question was also about pH sensing. It was about the ecFLEX, but the first question was also relevant to the second question. And the second question is unusual because we can get vinegar and bicarbonate to work on the ecFLEX. Maybe it's worth locking down that chloride concentration in those samples, and that maybe then allow things to behave better for the person. For electrochemical measurement of CBD and THC, you can do it directly or indirectly. We've tried both. Which way you go depends really on the application. Customization of screen printed electrodes. I would always suggest customization not too early on in a project. Unless you're well funded, don't go down the customization route. If you want to have ZP hypervalue electrodes, for example, we can brand those up for you, really no problems. And the lack of glucose response absolutely come into you've got to be careful in science. You can only ever be 99.999% certain, but I'm pretty certain that this person they need to change from carbon to platinum, and then they'll find they've got a much better linear range. So I think that just takes me to say particularly thank you to Aftab this morning. Lovely to see you again. Any questions, Aftab, give me a shout. And thank you to everyone else. Take care. We're coming up to the weekend now, so have a good weekend. We'll do this again next Thursday, 8 a.m. As you can see, if you've got any questions, send them in. We do spend a lot of time preparing and thinking about the questions, so they're appreciated. And I just want to say thank you. All right, take care. Bye-bye.